Okay, welcome to Module 2. Module 2 discusses humans across the landscape before we get into regions specifically. What I want to do today is we're going to introduce very simple concepts, that of human population distributions, and then the concept of population density. So again, relatively quick lecture. What I also want to point out is that this is the first module that you're going to have a quick write assignment. That is, I'm going to ask you to do some things on a specific website, and then you'll be working from that. So a couple of the terms that I'm going to go over in this module mini lecture, you're going to apply there. So let's get started. Okay, first of all, when we talk about population and population density, these are two different terms. And I need you to understand the difference between them. Population, when we talk about human population across space, one way we simply say is how many people are there in a given area. So in this case, what we mean by global population, that area is going to be the total within a country. And so, for example, the world as a whole right now has approximately 7.6 billion people. That's a lot of people. The United States has about 329 million people. That makes it the third most populous country behind China and India, both with excess of 1 billion people. Now, the problem with those numbers is that China, India, and the United States are actually fairly large land areas. And so it's somewhat easier to fit people into that. There's more resources, more land for the people. So sometimes that number is not that meaningful. And instead, we tend to work with the idea of density. So here's the world in terms of human population. Now what we can see is India and China well in excess of 1 billion people. And then you'll notice though, and I'm going to kind of point out these areas, what we see here is the United States, Brazil are also very, very high population. You'll notice both of those fall into the over 200 million category, but so does Indonesia. And that's where this idea of population versus population density becomes a really important question. If you think about fitting 200 million people into the United States or into Brazil, there's a lot of land. But when you think about putting that many people into this very small island archipelago, it's a whole different story. So in those cases, what we really want to talk about is population density. And again, the two that you need to know for the quiz are arithmetic density and physiologic density. So population, when we talk about a population number, it's just the number of people in a country or in whatever, might say a state or a county, etc. When we talk about population density, it's per unit of measurable area. So we say population density is people per square mile. Okay, that's a simple arithmetic density, whatever the unit of area. So we take how many square miles in the United States, we take the number of people, and we say we have 300 million people, and we have this amount of land area. That gives us an arithmetic density. Now, even that number is a little bit problematic because a lot of land in many countries is not usable. It doesn't contribute to how people, if you will, get along. And so that's why we've come up with the concept of physiologic density. Physiologic density is persons per unit of croppable land. Arable land is another way of saying that. And so that means land that is usable to produce crops, to produce food. Okay, so again, arithmetic density is divided by a number of people divided by the total land area of a country. Physiologic density is the number of people divided by the amount of land in that country that is usable. And let's take a look at these two concepts. First of all, here's Slippery Rock's campus, and we're going to do a quick idea of what density change means. What I've got here is 10 people, those little red dots, are 10 people per square kilometer. That's roughly a square kilometer of the area around Slippery Rock. And what you'll notice is that's a lot of land for each one of those people. Quite a bit of space to occupy. Now, if I increase that, that's 100 dots in the same area. So a population density, arithmetically, of 100 looks like that. Still looks like there's a fair amount of land per person. Now, it's 1,000 people. We begin to see that at 1,000, this is beginning to be really kind of well used. That's 10,000. So when we get to 10,000 people per square kilometer, and there are parts of the planet that have that as an arithmetic density, we realize how much land is necessary. Again, each person has very little of that kilometer left. Now, remember, if we go back, what I want you to think about is if we now looked at this and we said, well, only the land, buildings don't count as arable land, roads don't count as arable land, forested area doesn't count as arable land. Imagine Slippery Rock, and we can only see these areas that used to be farmland here and here, and that was all, and maybe even the grass here. Imagine if we had to fit all of those people into those areas, or more importantly, we had to feed all those people from that area. So that's the difference between our idea of physiologic density, land usable to produce food per person, arithmetic density, just simply the square meters or square kilometers or square miles of land within a country per person, or simply the population, how many people in a country. Now, we're going to look at where people are, and this is kind of, remember, think about our geographic questions. We start with phenomena, people, their distribution, okay, where are people located, and then the question of why. That's what we're going to get into next. That's it for mini lecture number 1. We'll see you in the next one.